Hello, this is Abhishek Gade, and today we are going to learn about SimpleX method. So the prerequisite to learn about SimpleX method is the graphical method LPP, that is linear programming problems. Okay, so let us start. So yeah, we have a explorer, a mountaineer. He has an idea. He wants to do something in his life. He wants to go to the highest peak. Okay, so he can see two mountains nearby. First is this, second is this. So okay, this one is the peak here is at x1 y1, which is lower than x2 y2, which is the peak of another mountain. Obviously he will decide to go this side. Okay, yes, this person has reached the highest peak, but now if he sees both on both the sides, he finds one mountain here, okay, which was small. He knows that, but now another mountain is there, which is which whose peak is higher than this mountain. What will he do? Yeah, his aim is to maximize his height. He wants to reach at the highest peak. Okay, so he will again move this side. No worries. Then, okay, now he has reached there also. Now he sees on both the sides. This side, okay, the peak is lower. This side, okay, the peak is lower. Hooray! He has won the game. He reached the highest peak which was possible in his locality, in his constraints. Okay, so this is the basic idea for simplex method. This is how it works. Okay, so simplex method. Simplex, do you understand the meaning of simplex? So simplex refers to a polytope. But you will tell me, I don't know what is a polytope. See, generally the graphical method we do is for 2D. Okay, so the constraints are only two, maybe x1 and x2. There is nothing like x3. So it is easier to plot them on the graph. Okay, someone intelligent will say, I can plot x3. If x3 is also there, I can plot even that. So x1, x2, x3, it's very hard. I'm telling you, it's very hard. Still he says that I can draw it. Okay, draw. But now I will tell you, I'm adding one more, x4. Now what to do? x5, what to do? Impossible. You cannot plot them on a 2D graph. You cannot show them through different 2D graphs. Okay, so there is where the need for simplex arises, simplex method. So understand what is a polytope. I do not want to give some definition. Let us see the figure itself. Oh yes, it looks like a football. Okay, so yeah, it is a polytope. Actually, it is made up of different planes. Okay, which are connected to each other. It looks like a football, but it can be any shape. Okay, now what is this? But now this is nothing but the shape which is formed because of the constraints, the 3D constraints. Okay, these are all x1, x2, x3, x4, x5. So this shape is formed due to them. Okay, so the basic idea of simplex is, let us start from this point. Okay, so is the maximization achieved? The problem says maximize something. Okay, so is it achieved? No. See both the sides. Should I go there or this side, left or right or up, to maximize my current value? Okay, I'll go this side. Okay, another point arrived. Again I will see all the sides. Should I go somewhere else again? Okay, so doing like this, I will go through this path and finally reach a position when I look on all the sides, okay, all the possible sides. But no, I have already reached a position where I cannot find another side, another vertex better than me, which will maximize the value. And hooray, that's the point, you have reached optimal solution. Okay, so what you are doing is you are walking on this polytope. You are walking on this polytope till you achieve the solution, till you achieve the optimized solution, the best, the maximum value. Okay, see, understand this polytope is going to have some limited vertices. So obviously you have some hope that yes, I will reach sometime, like after some time, to the maximum solution, and with that hope you start the simplex method, and yes, you achieve it. Okay, so let us start with the actual simplex method, the tabular format. So see, this is maximize z equal to 6x1 plus 5x2. So this is nothing but a objective function. Okay, but then it is subjected to this constraints: x1 plus x2 less than equal to 5, 3x1 plus 2x2 less than equal to 5, and x1 and x2 greater than equal to 0. You would be telling me, why didn't you took x3? Oh, you were telling me like, oh yes, x3, because simplex method we are using for x3, na? So because x1 and x2 so we can directly do on graphical, na? So why are you taking this example? So actually I have took this example so as to make you understand. This will be the easier way to make you understand. Okay, because we are also going to see what is happening in the background. Okay, when we do some things, when we change the table. Okay, so see, this was the original format. Okay, so yeah, this is the objective functions and these are the constraints. Now what will I do? What will I do? I will convert them. I will convert them into standard form. Okay, standard form by adding the slack variables. See, x1 plus x2 less than equal to 5. Where should you add something so this inequality sign is removed? A left hand side or right hand side? Obviously left hand side. So yeah, that is called as the slack variable I am adding here. Okay, so similarly here something should be added, right? So I am adding here s2. So two constants I have added s1 and s2. But are this s1 and s2 going to affect the objective function? No, we are adding it for our understanding, right? Okay, the slack variables, it is not, it has no role in changing the objective function. So what will be the coefficient of s1 and s2? 0. Both of them will have 0 coefficient. Okay, so let us move. Now all these things what we are doing is we are going to write it in a tabular format. Right, the most important part starts now. Okay, so now please concentrate. So this is the way how we need to start with the simplex method. Write this table. So this b, what does it mean? The B stands for basis which contain the basic variables, right? CB, what does it stand for? Coefficient of basic variable in objective function. Okay, then RHS, so right hand side value. Okay, CJ, okay, CJ is nothing but showing you the profit value. Okay, okay, so then x1 is one variable, x2 is one variable, and then s1 and s2 are slack variables. Okay, so yes, done. This all things you need to remember, the terminology, right? So let us start now. So just write this, make the table, and what would you do is how to start this simplex table, how to start it. So first step is decision variables need to be set to 0. Okay, decision variables need to be set to 0. So s1 and s2 you will first take it into solution. Okay, so say in the basic, like basic variables. Okay, so what are the coefficients of s1 and s2? Obviously I showed you, it is 0. Write them. Okay, written. And what are the RHS values? 5 and 12. Okay, and see 1 1 1. Okay, this is for S1. Remember, S2, for this constant it would be 0. The coefficient I am talking about. Okay, for second equation it is 3 2 0 S1 and 1 S2. Just write all these things here. See, RHS means 5 and 12, this value. Which? This value, right? This value. 5 and 12. Okay, I have written everything. Done. Now what to do? Okay, this standard format you need to make at the beginning of every simplex problem. Okay, so next, what is this Zj? I need to write something called as Zj. So Zj will give me the profit value. Okay, Zj will give me the profit value. Cj is nothing but the coefficient of the variables in the objective function. Cj is the coefficient of variables in the objective function. So what would be Cj minus Zj? That we need to find, but I don't know how to find Zj. So how to find Zj? So now actually what does this Zj shows? First the Zj row, this is the Zj row. Before finding it, what does I'm like thinking like what does it mean to find Zj? Okay, so it signifies the amount of outgoing profit by introducing 1 unit of non-basic variable into basis. Didn't understand? Let it go. So let's start. Zj, finding Zj. So multiplying CB with x1, 0 multiplied by 1 plus 0 multiplied by 3, it would be 0. Again same thing, 0 multiplied by 1, 0 multiplied by 2, it would be 0 if we add both of them. Again 0 multiplied by 1, 0 multiplied by 0, add them, 0. Similarly this also we will get. So this is how we get Zj. Now our aim is that Cj minus Zj, see we have found here Cj minus Zj. So this value should be 0 or negative, every value, and then only we can tell that the solution is optimal. So Cj to we already have na, and Zj we got it right now. Find out Cj minus Zj. 6 minus 0 6, 5 minus 0 5, 0 minus 0 0, and 0 minus 0 0. Okay, but it is not negative, not 0. See, 6 is there, 5 is there. Tell me, which is greater, 6 or 5? See, why we are doing this? Which is greater? Why we are asking this? So see, actually see, this is not our solution. S1 and S2 is not our solution. We want to find something. We want to find something which is our solution. So to find that, we need to add one variable and we need to remove one variable. See, understand. See, like you want to eat pani puri today, like evening, okay? So, but you have two friends, and one wants to eat pani puri, the other wants to eat vada pav. So, whom will you choose to go with? That vada pav one guy or the pani puri wala guy? Obviously, if you want to eat pani puri, you will choose the pani puri wala guy. So you will choose that person who is benefiting you. Okay, so that is the entering variable. Okay, and the leaving variable is one who is not helping you. Okay, to maximize something. Okay, so that is the basic idea. Okay, so Cj minus Zj, two values are positive. Which one is higher? Okay, this. So see, the arrow shows that the column is the pivot column. Okay, pivot column. And now see this full. This is the pivot column. Okay, done. Now pivot column is done. But now what we need to find is pivot row. Okay, so how to find it? Minimum ratio. This will give us This is the idea to find the pivot row. Okay, so minimum ratio is, okay, minimum ratio is the ratio of RHS to pivot column. What is RHS? 5 and 12. Yeah, we know that. So 5 and 12 is written here, divided by pivot column. See the arrow, the all the elements above that, okay, in the line of that arrow are in the pivot column. So 5 by 1 it is 5 and 12 by 3 it is 4. Now minimum ratio is ratio of RHS to pivot column. Okay, this is clear. Now this minimum ratio should be positive. Okay, we need to select the one which is positive and which is minimum. Negative 0 do not consider. We are selecting only the minimum positive. Okay, okay, so is 5 minimum or 4? Okay, both are positive, but which is minimum? 4. Okay, so I have shown an arrow. Okay, so what does that mean? Any idea? Clearly it means that this is the, what is this? The pivot row, and this was the pivot column. So where are they intersecting? Something is common, and that is this 3. So that 3 is called as the key element. Okay, that is the key element. Okay, the pivot element. Okay, okay, so Cj minus Zj, to check whether the first iteration is optimal or not, we are checking Cj minus Zj. Is Cj minus Zj all are they negative or all are they equal to 0? No, they are positive. So the iteration goes on. So we move on to the second iteration. Okay, but before moving on, let's see what is happening back. So we are right now here on, in the first iteration we are on the initial point. Okay, 0 0. Okay, we are there. Okay, but sorry, we didn't find any maximum value here. We also have other opportunities because we have two nearby vertex. Okay, see this solution we will get only at some vertex. Remember that polytope. Okay, so we will get somewhere on the vertices we will get the maxima, but we need to find. So the neighbors are this and this. So let's see what happens. We are going for next. So see, what we found out was this was the pivot row. For what we are calculating pivot row? Why? To know that who is going to leave. Okay, this S2 is going to leave, and who is going to enter. For that we calculated the pivot column. This was pivot row, this is pivot column. So x1 is entering to S2. Okay, see, but it x1 is going to enter S2. Okay, see here, this is the second iteration. These 3 lines show you. After that 3 lines we are going forward for second iteration. So the x1 has entered, S2 gone. Okay, okay, so let me clear the screen for second iteration. Okay, so down here, that is second iteration, this was first iteration. Okay, so x1 has entered. What is the basic variable CB for x1? What it is? Let me check. X1, yeah, it is 6. Okay, so I'll write there 6. And now how to change other things? Remember, these are important points. See this key element here, do you see? Make it 1. Make it 1 and make all the elements above it or below it as 0. Okay, to make this as 1, I have to do row operations. So 3 by 3 is 1, I got it. So 12 by 3 is 4, okay. 2 by 3, okay. 0 by 3, okay. And 1 by 3, done. So I divided everything by 3. Now something else needs to be done. What? We got one row. Okay, we have changed it. Okay, this one. This is clear. Now second thing, what to do now? The first new row, how do we get this? Okay, remember the technique. See, we want to make this 0 for all these things. Only we are doing this operations and everything. Okay, so already we got this as 1. So what will you do? This, do you see this full? See, wait a minute. Okay, so say this. Yes, so this is the old value, old R1 I can call it as, and this is the new R2. See, do old R1 minus new R2, you will get 0. 5 minus 4, 1. 1 minus 2 by 3, 1 by 3. 1 minus 0, 1. And 0 minus 1 by 3, it is minus 1 by 3. Okay, I got both the things. Okay, so finally my second iteration is also done. Same things now we need to repeat. We need to calculate Zj. So okay, Zj, how to calculate it? So 0 zeros are 0 and 6 ones are 6. Add them, 6. Again 0 multiplied by 1 by 3. 6 multiplied by 2 by 3. So it would be 4 if we add both of them. Okay. Then 0 multiplied by 1 plus 6 multiplied by 0. It's going to be 0. Okay, no worries. 0 multiplied by minus 1 by 3 and 6 multiplied by 1 by 3. It is going to be 2. So this is how we calculated the Zj value. What was Zj value? It was showing the profit value. Now Cj minus Zj is going to indicate whether the simplex table is giving the optimal value or not. Let us check it. Cj minus Zj. Cj, so we know it is going to remain same. 6 minus 6, 0. 5 minus 4, 1. Okay, 1. Then 0 minus 0, 0. And 0 minus 2, minus 2. Okay, so done with these 4 things also. Oh no, still one value is greater than 0. What was our aim? For maximizing things, Cj minus Zj for all elements should be less than or equal to 0. But 1 is greater than 0. So I think there would be a third iteration also. Oh no, but we need to do. What can we do? So minimum ratio. Okay, we'll find. See, this is the I got it. This is the, what it is? Basic, what it is? Pivot column. And now we are moving for pivot row. What will we find? What are we going to find for that? We will find minimum ratio. So minimum ratio, what is the formula? The formula is RHS upon pivot column. Again, RHS, so we know 1 and 4 is there. Upon pivot column, so this value. So 1 upon 1 by 3 is 3. And 4 upon 2 by 3 is 6. Okay, both are positive values. What was the rule for minimum ratio? The least positive ratio. That would be, along that, it would be the pivot row. Okay, so let me see. Okay, from 3 and 6, 3 is the minimum. So along it, that will be the pivot row. So this is the pivot row, right? And this is the pivot column. So the key element is 1 by 3, which I have circled. Again, we need to move for the next iteration. Okay, but before that, let's see what happens in the background. Now 0, 0, we didn't got anything. We moved here and we got 4 at 4 comma 0. We tried to find whether it was a maximum, it was giving the maximum profit or not. But no, still nothing we are getting. Okay, see how I got to know that it moved to 4 0 and not 0 5. See, x1 4 came na. I told you no. So that's why I know now this is 4 0 where we are, but still we have not got any value. So now I think we should move forward. We should check other points also. Okay, we will check. Now this is the third iteration. Okay, third iteration. Below this line we have third iteration. Some happy face is there here. Seems the iteration is done. Okay, that's cool. Okay, so again we now need to iterate. So below this line there is it is the third iteration. Okay, so again how to find? We need to make this 1 by 3 as 1. I will multiply all these things by 3. So we will get this values. Okay, this values. Wait a minute. This values we are going to get if we multiply by 3. Because we want to make the key element that was previous as 1. So that we will get all the new row values. For R1 we got it. Now what is our aim? This 2 by 3 should become 0. What did I told you? The below key element and above key element, everything should be 0. So how to make 2 by 3 0? Remember something you found new. What did you found? Okay, this new you have found 3 0 1 3 and minus 1. Now what will you do? Adjust something, do something with that R2. Okay, R2 old and this new R1, do something, some operation so that it becomes 0. What will you do? 2 by 3 and 1 is there. What to do? 2 by 3 minus 2 by 3 multiplied by 1, it is equal to 0. Okay, so I can do one thing. I can write that, I can tell that R2 old. So this R2 old minus, okay, wait a minute, to be clear let me remove this. So R2 old, okay, R2 old minus 2 by 3 the new R1, okay, will give you this value. And why we are doing this? Only to get this as 0. Understood? So R2 old minus 2 by 3 new R1. Okay, R2 old. Okay, but minus 2 by 3 new R1. Okay, this is the first row and this is second row. I am calling them R1 and R2 for your reference. So they will give us the new values. Now the basic variables for X. See, actually there was one point to be noted. So what to write here? Why x2 has came in the place of s1? Do you know? See, because let me go to past second iteration. See, s1 was the, what it was? The leaving or entering variable. It was the leaving variable, and in this direction, oh, I go, okay, x2 was the entering variable. So if you have understood, s1 and s2 are removed and x1 and x2 took the place. Okay, so for x2 will take this s1's place. Okay, so yeah, we are doing that only. So that's why here x2 and x1, we know what are the coefficients for x2 and x1 in the objective function, right? It is 5 and 6. So we have written them. Again we will find zj, cj minus zj, same process. I am not going to tell again. Okay, so cj minus zj, some important thing you can observe here. Can you observe here? Because that's why this person is happy. I was thinking, why is he happy now? He has nothing to do now. That's why he's happy. See, cj minus zj, everything is 0 or negative. What does that mean? It means only one thing. Now optimal solution has reached. Nothing to calculate forward. Nothing. Okay. So this solution has reached. Stop now. Do you know I told you about the mountains at the beginning of this lecture? So the last point where you can see that, okay, if I go to that mountain, I won't reach maximum height than what I am now, right now, currently. Okay, I see on the other side, same thing. I cannot go there. I am at the highest point right now. Nowhere to go now. Okay, so that is what we call as optimum point has reached. Okay, so yeah, First I moved this side and then I moved this side, and at 2 3 x1 x2 2 3, see this x1 x2 2 3, I got the finally I got the optimum value, right? So just keep it in the objective function, z equal to 6x1 plus 5x2. So 6 2s are 12 and 5 3s are 15. Add them, you get 27. But this was all about maximizing. So what for minimizing? Everything remains same. Only difference is Cj minus Zj now need to be positive, right? Cj minus Zj need to be positive to achieve greater than equal to 0 to achieve that optimal solution. Okay, for minimizing. For maximizing, it is Cj minus Zj should be less than equal to 0. Okay, for optimal solution. Okay, but yeah, so can we just summarize the procedure? Yeah, we will do that. So first step is formulate the linear programming problem. Such a set of things will be given to you. This is happening, that is happening. So formulate the linear programming problem by yourself. Formulate the constants. See, this I am telling you for the actual world. Okay. Second, convert these constants into standard form by adding slack variables. Third, what we need to do is first basic step is the third step. Okay, so third is equate all the decision variables to 0 and find the value of slack variables. Okay, fourth, draw the simplex table, check whether the Cj minus Zj are 0 or negative. Let's move on to the next step. So while forming the Cj minus Zj table, okay, we are calculating the minimum ratio, that is RHS upon pivot column values. We are finding the pivot row, pivot column. Okay, first we are finding pivot column and then pivot row. Where they intersect, we find the element. We make that element as 1 for the next iteration, and all the values above and below the element should be 0. So we adjust. We make the operations, row operations, such that this happens. Okay, we actually relate the new values we obtain with the old values to do this, and finally when Cj minus Zj is less than or equal to 0, we say that the optimum solution is reached. Thank you.